Welcome to The Explainer. Today we're diving into syntax, which is basically the invisible architecture behind every single sentence you speak, hear, or even think. It's like a hidden rule book running in your brain, and we're about to figure out how it all works. So let me start with a puzzle for you. Just instinctively, that you can say, who do you think bought the bread machine? But you would never ever say, who do you wonder what bought? Right? That second one is just a jumble of words. It makes zero sense. But here's the question. How do you know that? Did anyone ever sit you down and explicitly teach you that one specific rule? Almost definitely not. And that is the mystery we're getting into today. And, this puzzle gets even weirder when you look at kids. The language they actually hear is a total mess. It's full of mistakes, people talking over each other, sentences that just trail off. And when parents try to correct their kids' grammar, it usually fails, sometimes spectacularly. There's this famous case of a kid saying, want other one spoon, and no matter how much his dad tried to get him to say the other spoon, he just wouldn't. But somehow, he still ends up mastering the grammar perfectly. This whole situation is what linguists call the logical problem of language acquisition. So how on earth does the mind solve this puzzle? Well, the answer seems to be that we don't learn language the way we learn, say, algebra in school. We acquire it. It just happens subconsciously. It feels a lot like magic, but it's not. The most famous answer to this puzzle came from the linguist Noam Chomsky. He came up with this idea that we are all born with what he called a universal grammar. Think of it like a pre-installed operating system for language. It's this innate blueprint that gives us the basic scaffolding for any human language, and that's why a child can build this incredibly complex system from such messy, incomplete data. Okay, so if this blueprint really exists, how in the world can we study it? I mean, it's not like you can just open up someone's brain and see it, right? Well, this is where the actual science of syntax comes into play. Linguists like Andrew Carney have developed these amazing toolkits, like this very textbook on syntax. But you have to think of it less as a book of rules to memorize and more as a guide for reverse engineering that blueprint that's already inside our heads to see how it's actually built. And the first huge discovery they made is that sentences have a hidden architecture. They're not just a flat string of words, one after the other, like beads on a string. Nope. They have a rich, hierarchical structure with parts nested inside other parts, kind of like how a building has rooms inside of floors and floors inside the whole structure. And the core idea here has a name: constituency. It just means that words naturally group together into phrases, and those phrases then act like single solid units. So in a sentence like, the very small boy kissed the platypus, the whole chunk, the very small boy, acts as one block. That's a constituent. These are the real building blocks of language, not just the individual words. Now, you might be thinking, okay, words clump together. So what? Why does this even matter? Well, this is where it gets really, really cool, because this hidden structure isn't just some neat little organizational trick. It is the absolute key to how we create and understand meaning. Without it, language as we know it would literally be impossible. Let's take a look at this classic example from Carney's textbook. The man killed the king with a knife. Seems simple enough, right? Pretty straightforward, but this sentence is hiding a secret. Just think about it for a second. Who has the knife? Does the sentence mean that the man used a knife to do the killing? Or does it mean that the man killed a specific king, the one who happened to be holding a knife? The string of words is exactly the same, but it can mean two completely different things. How does your brain handle that? The solution to the mystery is all in that hidden structure we've been talking about. Look at this first diagram. You can see that the phrase with a knife is attached to the action, to killed. That tells your brain it describes how the killing happened. Now look at the second one. Here, with a knife is attached to the king. Now it's describing which king we're talking about. The words didn't change, but the architecture did. And that's what reveals this incredible, invisible structure our brains use to make meaning. It's amazing. So, how do linguists discover these hidden structures? It is definitely not guesswork. As Andrew Carney explains, it's all about using the scientific method. They start by observing real-world data, sentences people actually say. Then they look for patterns and make a generalization. From there, they form a hypothesis, a guess about a grammatical rule. And then they test that hypothesis like crazy against even more data, tweaking their theories as they go. And all of this work, all this mapping of sentences, it leads to a much, much bigger picture. Because when you study syntax, you're not just studying language rules. You're actually starting to draw a map of the human mind itself. The very existence of this deep, hidden, rule-based architecture for language is just powerful, powerful evidence that our brain is running an incredibly sophisticated computational system. It's like this engine for creating and processing structure that's always running completely below the level of our conscious thought. And that brings us to the most important point of all. When we study syntax, we are not just studying language. As Carney puts it so perfectly, we're studying a core part of human cognition. Syntax is a cognitive science. It's a window into how our brains are actually wired. So at the end of the day, understanding syntax helps us answer some really big questions. It explains how kids can master language against all odds. It explains our amazing creative ability to make and understand a basically infinite number of new sentences. It shows us how our minds untangle ambiguity in a split second. And it points toward that universal blueprint of language that connects every single one of us. So we'll leave you with this final thought to chew on. The simple, everyday act of speaking a sentence relies on this unbelievably complex and totally invisible structure. If something so fundamental has this much depth hiding just beneath the surface, what other complex systems, what other hidden rule books are just waiting to be discovered inside our own minds?